Software as part of the solution or software as part of the problem? This is the to be or not to be question in the sustainable software engineering space. You probably have heard this before as well, but when I first got asked this question, I was in a cross-industry sustainability consulting conference, and there was this guy standing in line before me on the food truck, waiting to get the food, and he just randomly popped out that question. And I had never made thoughts about it before, so I got into that thinking mode. And I was completely unprepared, it came unexpected, and it took me quite a while to think of an appropriate answer. And by the time that I wanted to answer, sadly that guy had already taken this food and was not even there anymore. But nevertheless, it stuck with me. It stuck with me because generally I do not agree that things have to be a 0 or a 1. There is a spectrum of possibilities in between. And this is the same with software and sustainability as well. It will be great if we all could be working in a net zero product in a climate tech company, but the reality is that we cannot afford to do that. There is not much necessity out there. But what we can do is, regardless where we work, is that we can make existing products and existing technologies that we have more environmental friendly via conscious software design. And as I will show you later on, this requires less work than it's actually thought to be. So a little about me. I am Bjorna Kalaja, a software engineer at For You and Your Customers Vienna. We are a software consultancy company specialized in digitalization expertise and mostly just support companies into understanding their digitalization process across multiple layers. Coming back to this one-sided conversation that I just told you about it left me thinking. It left me thinking, and I started then also searching a bit the facts. I'm not going to bore you with facts, just 2 of them. First one, and the most important one for me, is that the carbon footprint of IT and communication technologies is estimated to reach 14% by 2040. And that number is huge. It is huge because 2023, this number was only 4%. So there is an estimated increase that we do not know yet what do we do with that information. So we need to process it, and we need to have a plan in place to lower that number. And we probably all assume, why is that so? We are in an AI era. We have the data centers being one of the biggest contributors to those greenhouse gas emissions. And there are video streamings, there are a lot of contributors on that space. And while there are solutions already out there, it seems that it is not enough. It seems that we need to go deeper on every software project that we develop so that we can offer a better number for the future. Now, I really hope that it does not come to that number by 2040, but it is still something that we need to acknowledge right now. Another fact is that as part of the European Green Deal, digital solutions are considered now Scope 3 emissions. Fancy words, all these ESG spaces, but what it actually means is that every company that underlies these sustainability reporting directives, sooner or later will be faced with the fact that they need to disclose their digital product carbon footprint as well. What it means for us is that if you have any customer, or if you are in a business of selling online goods, for example, you need to disclose that carbon footprints, that it comes from those sales of your e-commerce platform. And for us as software developers, it means that we have to be accountable on that. We have to provide a solution to our customers. How can we measure it, and what do we measure in the first place? And this is regardless if we are working on a product team, on a platform team, or on a software, or providing just software expertise. We still should have accountability on the product that we deliver, because there is nobody out there that can do it for us. Not the clients, not the stakeholders, not the management people. And this area of expertise has already started blooming. There are a number of companies who provide that service. So it is also a good business area to be active on it as well, to be honest. If you do a Google search, a quick Google search on the terms of green software and sustainability in software, you come across to a number of keywords. sustainability software engineering, carbon footprint, eco-conscious software design, eco-friendly software development, low-impact software design, sustainable computing, and many, many, many others. And in addition to that, not only keywords, there are actually also pretty good guidelines that are available out there. For a quick overview, how can we ensure that we have a green architecture in place? And it's really good to have that, because a couple of years ago, there was mostly no information out there as to what we can do. We could just wonder about it, but there was no scientific backup data on that. So this is actually one good thing that we have. And among of those keywords, green mining is my personal favorite one. And it is so because it is the field in software that investigates the changes that happen in the energy consumption of a software solution, and it links back those changes, whether it is increase or decrease, to the changes that are performed in the software code itself. Which means that if we have a method to regularly measure our software solutions' carbon footprint every other week or every 2 weeks in a sprint work, we can link up with every increase or decrease to the work that was done in the last 2 weeks. And this is extremely powerful. It is powerful because it helps us to put sustainability work not directly targeted at the whole system, but at parts of the system. At best, at separate software components that we know that are responsible for that increase or for that decrease. Or in other words, if we deployed a feature that explodedly by 50% increase the energy consumption, we undeploy that feature and we are done with that. So it is a very, very powerful tool that we can use in software engineering and in sustainability work in our software projects. Now I would be really interested in the second questions. I know it is a cliche, but can you please tell me how many of you already consider test coverage as part of your systems? How many of you regularly measure it? Yeah. And you will assume the next question, I think. How many of you already consider the environmental impact? Oh, thank you. I would like to talk to you later. But it is expected. And it's not only expected by me, it is expected by a huge number of scientists out there that investigate this thing. Environmental impact is not established yet. It's still, there is a long way to make it standard in our software projects. We do not measure it for a number of complexities that I will get into that in a little bit. But the fact is, we just ignore it. We ignore it and it's not there. On the other hand, test coverage is well established. We all do it for different reasons. We have people who are pro to it. We have people who are against it. But the fact remains that it is part of our daily life, and it will be probably for a long time in software as well. So what is missing? What is this missing link between we understand that we have a problem here, we understand that there is a need to change something, and we still do not have it present in our daily work? And we are past that way in the climate change and the climate problems where we can just ignore stuff. And there are a number of challenges that it comes when we discuss those questions. One of the most obvious ones is awareness across stakeholders. Awareness across executives and clients is actually basically not there. The majority of the decision makers, the environmental work is still an abstract concept. And in software, we usually enjoy those fast feedback rounds. You know, it is the core of agility itself. We are used to it. We deploy something, we get an immediate feedback, and we enjoy this kind of work. But with sustainability work, this feedback round, it's not as quick. We need to be a little bit more patient. And this is where the problem also happens. We do not see it, and we do not understand it. When it actually happens, we cannot link it back to a specific thing that happened in the past, and this leads to resistance. This leads to resistance into putting the work that we need to do there. And we know how it goes into in the projects, like time is money, we need to justify everything that we do, and all those stuff that everybody has to deal with daily. So it is, at the end of the day, our job as software engineers, as software developers, as part of any software product, to talk about the importance of sustainability, and not only when we are developing something, but ideally when we start concepting something. From the first talk that we have with our customers, from the first moment that somebody comes into the room and says, hey, can you give me a quick estimation to do that project? Part of that estimation, it has to be the sustainability work as well. And this is where we start building acceptance and we start raising the awareness across the stakeholders and across everybody who is involved in a software project. And on the other hand, we have also, as I mentioned, the European Green Deal, which will be our support mechanism on that. I hope that it comes and it's not postponed to a further deadline, but as soon as it comes, companies will be forced to think about it. And once they are forced to think about it, we better be prepared with solutions because we do not have them time to lose anymore. Another challenge that we have, sadly, is the missing awareness on the software developer community aside itself. So doing this environmental work and improving this impact that the software has is usually related to extra work needed to be done, and also work that is done with a specific goal in mind that consists of complex tasks that we need to solve and nobody knows. So it's sustainability, it's out there, it's not my problem, I don't know how to solve it, I need expertise. And this leads to avoidance. But as I will show you then later on, it's actually pretty easy to do those first steps and to get into the sustainability work of any software application without even thinking that you are doing sustainability work. Last but not least, data. Generally in the sustainability space, especially when it comes to reporting or having to do some GHG reportings, across the supply chain, one of the biggest challenges that we have is data. And this is because until a couple of times ago, we did not even know what data is required to be collected and if that data is really needed in the future. So what we did by default, we disregarded everything, or we collected exactly the data that is for no use today. So data is a really big challenge that we have to solve, especially for the reporting purposes. And with that challenge, it comes also the expertise. So we need to train our teams, our software teams, to think in the data perspective as well. What data do we need? How do we collect those data? How do we analyze those data at best? And so that we can avoid the costs that are related to those changes as well. So keep in mind and never underestimate the data challenge that comes with sustainability work. So going a little bit more into the details. What I usually see in the climate tech space is that there is a high desire for teams, for people, startups to build a single product that supports solving a specific problem in a specific industry or parts of industry. And the best example for that, 2024, it has been the fashion industry. It has the boom on apps, on startup, on the climate tech space, because fashion industry is one of the biggest polluters that we have also out there. And this is a good thing. This is an amazing thing. We want to have that. But when I ask the question then, are you aware of the impact that your solution, that your digital product that you are now providing as a solution to a specific problem, are you aware of that impact that you have in the environment as well? And what I get asked back is, how do we do that in an efficient way? So how do we measure it? And this is coming from people who already know the sustainability. They know the data, they know the terms, they know everything. And they still, when it comes to the techie part, still are clueless about how do we do such thing. And this is important to know. So it's important to know this kind of stuff because at the end of the day, if you want to solve a problem in the sustainability area, the impact, the real impact that you will have is the carbon footprint that you saved, extract that to that, the carbon footprint that you produced. If you get at the end of the day a positive number, you're good to go. So you have saved the world. If you get a negative number, do not get discouraged. There are options to turn that number, but there is still room for improvement. So fairly enough, all of this raises a lot of questions. What metrics can we use? What does it make sense? There are a lot of keywords used when talking about that, like carbon footprint, carbon intensity, power usage, power efficiency, energy consumption. Which one of them is easily integrated into our daily workflows as well? Once we have that, how do we measure it? What are the common measurement methods? What tools can we use to have an overview? How does this measurement look like on cloud, or how does it look on premise? How good is it? How good can I integrate the tools with my current tech stack? And all of those questions. And last but not least, we have the metric, we know how to measure it, we get a number. How do we react? Because it is one thing being aware of the impact that your software has, which is a good thing in itself, but it is a completely other thing to consciously making changes on improving that impact. So let me try to quickly answer those questions in the time remaining. So recap, 3 things towards a greener software. What metric to use, how to measure it, and how to react once we get the results. And now here it is really worth mentioning that, because you already see energy consumption in there, the impact of a software, the impact on the environment that the software has, it goes beyond its energy consumption. It's not the only one. But if we improve the energy consumption of a software, any software solution or digital product, we already are making the fastest and the easiest way into a greener product. And this is why in the next sections I will mostly focus on energy consumption and carbon footprint without mentioning the other aspects as well. But just know that they are there. So the energy consumption, as you see it here, is a great metric to use, and it's great because of a simple reason. We have the global usage, global energy consumption, that it is already well documented. And the energy consumption of any application, it delivers a direct link to that usage. So in percentage, I know what percentage of the global energy consumption is directly linked to my application or to a single component that is in your architecture. It's usually measured in watts per hour, and it represents the consumption of a single component during the runtime. And it is extremely important, especially in microservice architectures, because we are able, using this metric, to pinpoint high amounts of energy consumption or energy leaks to a single software component, instead of this whole cluster of services. While the energy consumption is a great indicator of our environmental impact, it's not enough. It is not enough because the real impact is decided at the end of the day from the emissions that are released into the atmosphere. And energy consumption plays a role in there, but the network grid where your product is running plays an even a bigger role in that. So carbon footprint is used as a metric to find out how many emissions are released when my software is running at any given time. Ideally, a lower number indicates a more environmental friendly software. A higher number indicates that the software has potential to be better. And the network grid where the application is running on, as I said, is important. If the application is being supplied by renewable energy, if the network grid runs on renewable energy, we are good to go. If not, we have to lower that energy consumption. What we should keep in mind, though, is that most countries run on mixed energy sources, which means that even if we offload heavy operation onto renewable energy, we still have to be considerate with what we use. It's not an all or nothing situation, as I mentioned there before. So we have to still minimize the consumption, even if we are sure that we are running on green energy. Carbon footprint as a measurement on kilogram CO2 equivalents, it shows the total amounts of GHG gases that are released in the atmosphere. So knowing what to measure leads me to the how can we measure it part. And there are a couple of things here to consider. When deciding on a methodology, it is really important to consider the purpose of the data, the purpose of the results, why do you want to use those data? What do they serve? And also the granularity of the measurement itself. So a very important thing to ask your sustainability experts or your software team is here, do we want to have a general overview of our carbon footprint of our infrastructure, or do we want to know on a component level how much carbon footprint we are releasing there? If you host your solutions anywhere on the cloud, there are currently a lot of possibilities where you can get an overview of the carbon footprint. And this is mostly a system overview divided by resources. But if you have a microservice architecture there and you run your services in a Kubernetes cluster, what you will see in those reportings is the carbon footprint of your Kubernetes cluster. And this is not directly related to the single services that are there. If you have a small team, you probably can link it back with some reverse engineering. But if you have a big team, multiple teams that roll out changes multiple times a day, it is practically impossible. You have to work then on a software level. So the question is, do we orchestrate for awareness or do we orchestrate for maximal improvement potential? And once we know that, we have to make the decision if we want to do it ourselves or do we want to use a tool. And I've done it myself. I do not recommend it. It's painful, so do not do it yourself. Find a tool. And there are some stuff to consider also when finding a tool. You need to verify the underlying models, what the tool uses. Because at the end, the data that your tool will need to calculate a number, it will come from your application. And if you're not able to provide the data, the results at the end will also be not accurate enough. Another thing is to check the integration capabilities. You will need to integrate it in your cloud or in your on-premise architecture, so please check the integration capabilities as well. And if you have any clients that need to fulfill any reporting directives, you need to check if the tool also provides those reporting capabilities, or at least clarify it beforehand if there is any custom logic that needs to be added in there. So now to the good part. How can we react? Now we know what metric do we want to measure. We know how do we want to measure it. And now it's the golden question, what do I do now with that number? For me, as a software engineer, it is important, as I said, to have a reliable tool that helps me, supports me into linking those changes, those energy leaks, into a change in the software code itself. And once we have that, it allows any software team for to react quickly on any changes that occur. And one powerful mechanism, one powerful tool that we have on software engineering, which will extremely help us to get better results, is refactoring. We all know what refactoring is. Our stakeholders know what refactoring is. Whether they come from the technical or non-technical background, they have just accepted the fact that developers and refactoring are best buddies. There will be the tech dev stories. We will push to get those tech dev stories. So everything refactoring related is already, that discussion has ended. No need to discuss that anymore. So we can rely on refactoring, that it will be part of our work. And now the best part is that refactoring is linked in the research to improve the environmental impact of any software solution. And this is very helpful for us, as I said, because it means that we can integrate sustainability work as easily in our daily work without needing to plan, to do any extra planning, to do any extra talk, to do any extra costs. So I will give you some examples now. 2023, I worked on a case study where I researched the impact that refactoring code, it was a well-known refactoring kata, and refactoring this code for the solid principles, how does this impact the environment? The legacy code I did the measurements, I did the calculations, the initial metric calculations on that, and this was then some mathematical model that I just implemented myself. And then after that, I refactored the code 3 times. One for the single responsibility, one for the open-close principle, one for the list-off, and one for the interface segregation. And what I saw there, the results were extremely shocking to me. For every refactoring done, there was a significant improvement in the energy consumption and its related carbon footprint noticed. And you can see it here on the table. The initial code metrics are around at 2.13, and everything on the third column is lower than that. If we are talking on percentages, we have the interface segregation principle with up to 40.4% improvement. To put that number a little bit on the perspective, an LED light bulb that we all probably know consumes 2 to 10 watts per hour, depending on the producer. So these are not unrealistic numbers in the real life. These are numbers that have an impact, and this case study was done on a software code that has 30 to 50 lines of code at most. Now, if we imagine the same thing on a large-scale application with multiple users a day, millions of users a day, what is the change that is expected? Now, I'm hesitant to say numbers, but if we are anywhere on that area, if we are anywhere on 10% improvement, it would be huge. It would be really, really great. And what it cost for me, it was just to be a good programmer, do solid principles, and nothing else. And this is not the only one. So we have a number of other examples as well. Among the group of composing methods, extract method, as simple as that. Do not allow duplicate codes, do not allow long methods, just extract those methods. Consider using this technique because it is linked to having a significant improvement in the environment impact as well. And here in this code snippet, we have a print receipt method that does a little bit too much. So what we do is we just extract that information into 2 different classes, and job's done. So it's pretty basic Java code. Again, the same. Another group of refactoring techniques, moving features. In this case, it is even more wild because we are not even removing code. We are just shuffling code around. We're using the move method, and the move method is used usually when we have a class that accesses data of another class more than it does of its own. So what we do here in this example as well, we have a calculate discount that needs the order's total price, and we refactor it for the order processor class to be completely gone. It's totally useless, and we have the order class that just does everything. So we have no object instantiation of another class that is completely unnecessary. And this works because it reduces the CPU cycles, and less CPU cycles, we have a better energy consumption. Another one, simplifying data structures. We change the variable types, so we make sure that the correct data types are used. In this class here, we have a user ID, which we know that it might be integer, for example, but we use a string. So why use a string? Just use the correct one, and you will initially have a better energy consumption as well. This is extremely powerful when it comes to data structure in SQL or any sort of database or relational storage. Because choosing the right data types on an SQL, when you define a table there, it's extremely, extremely important. And there are a huge number of other examples that I could give you, but in generally what I would like to say is that check the good practices. Now here I have listed only a few of them, but there are a lot of more of them available. So keep the input-output into a minimum. Use efficient data structures. Rethink everything. In 2 weeks, 6 weeks, 8 weeks, rethink everything from the beginning and see if you can improve there again. Use data compression anytime that it's possible. It really helps. Consider the programming language that you use. If you have a little bit of autonomy in your team and you can choose anything that you want to choose, consider it. Like there are studies that show how much every programming language that we use consumes on energy. So there is room for improvement there as well. And consider the design patterns that you use. For specific problems, there are specific ways to solve a problem, and there are also a range of opportunities that we have there. So consider and double-check every decision that you have. So last but not least, what I would like you to take away from this session. Sustainability on software is not an all or nothing problem. I said it before, there are many aspects of sustainability work that you can do on a software. Reducing the energy consumption is one of them, but there are a lot of other aspects as well. So if you cannot make sure that you have a minimal impact on the energy consumption, make sure that you work on the other aspects. For example, make sure that your code does not get thrown away every couple of weeks, but it actually stays there where it's supposed to stay. Another thing, environmental impact of any software, it should be considered as part of all the phases throughout the software development lifecycle. It is not enough if we work on that only on the high point of a project where we have endless of money and we can do whatever we want to do. It is important to start from the beginning, from the requirements engineering, into the planning, into the architecture design, into the development, into the maintenance, and later on also when we disregard anything that we've done, because projects have a lifespan, so we know that. And on the plus side, if we do that for our clients, it means less cost. It means less resources. Resources are optimized. It will cost less at the end of the day. So it's not as hard as it seems to sell sustainability work on software as well. Working towards a greener product does not mean we need to reinvent the wheel. As I mentioned, in software, it is usually, we do not need to reinvent the wheel. We can use the stuff that is there. We can use the stuff that we already know, that are a common understanding between different people. And this applies here as well. Use refactoring, as I said, it's as simple as that. You don't even have to think about it. Just start doing it and you will see immediate results. Consider those best practices. And last but not least, measure it. So everything that we do, if we assume that it will be better, it will probably not be better. The only way to prove if we have a positive impact or a negative impact is if we measure it. So take the time and introduce those measurement techniques in your architecture and make it part of your daily development work. And on that note, I would be really happy if we share any more information on that area, if we collaboratively improve the sustainability work, and if we see how we can, as software developers, create sustainable software for you and for your customers as well. Thank you very much.
Thank you very much, and for this wake-up talk or wake-up call.
Yes.
I've already seen there are some questions coming in, so and we still have time for them. So, in my experience, more people in IT seem indifferent to environmental impact than in other fields. Do you agree? If so, why do you think that is?
I think I did not hear it well. More
okay.
people.
In my experience, more people in IT.
Yes.
Seem indifferent to environmental impact than in other fields.
Yeah.
Okay. Do you agree?
I agree. I definitely agree.
And if so, why do you think that is?
I think that it is this misconception. There are two things in my honest opinion. I think first it is the misconception that I need to have a lot of knowledge to do that work. And for that knowledge, most people do not really tend to get that deep into it. And why is that? Why is this misconception? I think because the stigmatism that climate change has. So climate change is a complex problem. It requires solutions across multiple industries. So how can I, as a single person, be able to solve something? So even if I change my application, there will probably be 1,000 other people who do not do that. So it's this feedback round, so I do not really see what I'm doing, and this makes it a little bit hard. And the second reason why I think it happens is because our stakeholders, I work in a software consultancy, so whatever we do, we need to sell it. And there are differences in clients. There are clients that are more open to trying new stuff. There are clients that are less open to trying new stuff. But if you work on a fixed project, you will have times where more money can be spent and you can try wild things like sustainability work. And there will be times where there is no money. You have to just deliver whatever they want to deliver. So the reality is a little bit different because at the end of the day, it's sadly, for me, it's very sad, but it's about money at some point. So, yeah.
Okay, thank you. Does the language the software is coded in play a part in the energy consumption? For example, Java, C++, PHP?
Yeah, I wanted to include a slide on that, to be honest. There are multiple. not sure the guy who posted it first, who did the first research, there is a paper on that. They investigated the energy consumption of an application made from different programming languages. And surprisingly enough, Java was on the good side of the table, and PHP was on the lower end. So I don't know, I need to reread that paper with the knowledge that I have right now, but I was surprised. But yes, the programming language really, really has a huge impact on the energy consumption as well. So my advice is also, when you know that you have to do some rework, consider using another programming language. Probably you are used to, I don't know, if you work on front end, you're used to use any JavaScript-related framework or so. Consider changing that framework that you use and see if the other frameworks are probably a little bit more environmental friendly. And if you are a Java fan, be open for other languages as well. Do not stay only on the Java world. So I'm a Java fan myself, so no pun intended.
Okay, thank you. What standard tools can you recommend? Available cloud solutions are like AWS, Azure, limited, also own implementation, CPU load time, TDB is inaccurate.
Mm-hmm. So my own implementation that I did, I used a mathematical model from Corallo. It is based on CPU usage, memory, data, input, output, and network consumption. And as I said before, I would not recommend to do that because it is unstable. It is actually pretty hard to pinpoint that if you run a piece of software in here, it is pretty hard to pinpoint that energy consumption to a specific process because everything depends. The real consumption depends also on a lot of stuff, like even the outside world, like how humidity and things like that. And there are tools available, so all cloud providers already have established their solutions. From Green Software Foundation, there is a really, really good tool that can be used. I think it's from ThoughtWorks. They have done amazing stuff in that direction. Plan A is also quite a powerful tool to use, especially if you have clients that come up with reporting strategies and reporting directives as well, so I would recommend that as well. And also what I personally have used quite a lot is also Climate IQ. This is also a very good tool to just quickly calculate the carbon footprint of not only in software, but any given operation that you have. So it's really powerful. Yeah.
Okay, thank you. I think we have time for one last question. In real-life projects, is this topic relevant only for large-scale projects or smaller projects as well?
Interesting one. In my experience, the large-scale projects are the ones that have the money and can afford to do it sometimes. But as I said, we do not have to plan extra things. We can do it with what we have. But the impact, it does not have to be on a large-scale application or not. So if you improve something, you improve it in a small application or improve it in a large-scale application as well. So the performance improvement and the environmental impact improvement that you might see, it might be bigger if we are talking on large-scale applications, but if you have 1 million small projects, that improvement will be the same. So it doesn't matter in which project you are working in, the improvement is an improvement. So it is better if you start doing something that not do anything at all. So that is definitely important. Yeah.
Thank you very much, Bjorna. So please give her one hand.
Thank you.